Well, good morning. I can't believe it's already here. What a busy year this has been. It is so good to have you here today. We're going to be talking about SQL Server Execution Plans. It's just a 101. We're just going to go through the beginning, peeling back that single layer. If you have any questions whatsoever, please put them in the chat window. I will take a break. And Tamar will then read off your questions. I'm going to miss the interaction with you because I feed off of that, and it's actually very calming for me to see your lovely faces. So right now I'm talking to us. I know I'm talking to you, but I'm also just talking to a screen. So bear with me here with that. So what I'm going to do is I'm actually going to turn off my picture so we can see more of the screen. Let me see if I can do that. My mouse is, there you go. All right, so let's get started with SQL Server Execution Plans 101. Oh, and I just hit that. All right. So let me go back. About me. You know a lot about me already. I've been working at that number of software development. The years are catching up and up and up. But I enjoy absolutely what I do. It's like putting puzzles together all day long. I have added SSRS, SQL Server Report Services, to my resume. What a fun ride that's been, and learning more each day. I absolutely love what I do. I love helping customers and developers make their jobs easier and better, I hope. So part of the community is with GLASS, with the, it's a users group for SQL Server. I also go to SPID, and this is all virtual right now. There's also SQL Saturday conferences. Excuse me, there's 8 KB online conferences. It's a SQL Server conference. It's a deep dive into the internals of SQL Server. It's an absolutely wonderful, a lot of times it's over my head, but I catch bits and pieces of it. Group Buy is an online conference that Brent Ozar has started, and that's also a wonderful, they're getting ready to start up a new conference soon. You'll have to check them out. Speaker, the virtual Fox Fest, yay, and SPID, GLASS, and then at Southwest Fox, and looking forward to meeting everyone again in person and live. And of course, I brought my buddy David with me. Right now, he's just in a picture, but he sure loves you guys and he misses you. So excited to be here. About this session, we're going to be taking a beginner's look at an exceptional tool called SQL Server Execution Plans. There is so much about this tool that we're just going to peel back. I want to say maybe one and a half layers of it. So we're going to be talking about how SQL Server prepares the execution plan, what type of execution plans there are, and we're going to look at, you know, what SQL Server is thinking when it comes to building these plans. We cannot cover everything about this very important topic. However, it's always important to start understanding it now. And what I encourage you to do as you build your SQL Server repertoire and you're going into queries, look what the execution plan is doing, and it will help you and enable you to be a better developer when it comes to SQL Server. Some SQL Server experience is nice, but not necessary, absolutely. But if you don't use it, you know what happens, you lose it. So our agenda, we're going to take a deep dive into the basics of the SQL Server execution engine. I mean, deep dive, we're going down to bare bone basics, ground level. We're going to get started with the graphical interface as well. There's so much going on in that picture of the execution plan, the show plan. We're going to look at that anatomy of the graphical execution plan. And we're going to start looking at some examples. We'll be talking about covering indexes and some other fun stuff, and how just one little new column or one calculation or how you define your tables can affect the execution plan and what SQL Server decides and how it decides to run your query. So let's take that deep dive into basics. So basically, what is an execution plan? And I'll talk about it, but then we're going to actually get into SSMS and the execution plans. So the execution plan is produced by the query optimizer and a lot of steps leading up to the query optimizer. And it's a way to calculate the most effective way SQL Server can run your query that you submitted. It's a way of showing you how it thinks. It can tell you what SQL Server may execute. It will tell you SQL Server what it did execute. And it's just a primary way for us as developers to see what part of the execution plan we might be able to tweak and get more efficient. And we can examine that by identifying pieces of the SQL code where the system I/O just totally goes through the roof, and what SQL Server, again, is thinking. Now, oops, I'm getting ahead of myself. I'm so excited. Okay. So what happens when we submit a query in SQL Server? Well, and what we mean by submitting, that's that select statement, that's the insert statement, the update, and the delete. And that's mostly what we're going to be talking about today. But it also gets into the DDL, the data definition language, where you go to create a table or create an index. SQL Server runs all of that code through the query optimizer into an execution plan. The processes around these queries can be roughly broken down into two areas. There is the processes that occur in the relational engine, and that's where we're going to be heavy in today looking at. And then there's a process that occur in the query execution engine. And tucked in there too is the storage engine. And but like I said, we're going to work mostly with the relational engine. So the relational engine can be broken down into two phases. There's the compilation phase and there's the execution phase. Now the compilation phase has a number of steps. There's a parser, an Algebrizer, and then the query optimizer. And then the execution plan is sent to the storage engine as a cache plan cache. We'll get there. And then the execution plan, it pulls it from storage, it checks it out, it checks that plan cache out, makes sure that it's still valid because you might have updated table statistics, the table structure might have changed. There's a number of things that it checks to make sure that that plan cache is valid. And then it executes the plan. So in a big picture kind of thing, you can see the relational engine, and there's this compilation phase where we submit the query, and then it goes to the query parser, and it checks to make sure that the query is well formed. And then if it isn't, it goes back, and you have to try again, right? And if it is good, then it outputs what most people call a parse tree, but some people call it query tree or the sequence tree. And then from there, depending, like with our example, it's a DML, a data manipulation language, it will then go to the Algebrizer. However, if it's a DDL, like creating a table, an index, there's technically the one right way to do things. So, so we'll go, and this is where we're going down. We're going down the path of the DML, where there's the Algebrizer. And then the Algebrizer tries to figure out the names of the objects, the tables, and the columns. It also will identify data types. And there are places where, in some of the examples, there are calculated fields types. So we'll look at all of those. The aggregate also determines the aggregates where there's group bys, max, mins and counts and those kinds of things. From there, it outputs the query process tree, and it's in a binary and a hash. And the hash is that unique identifier where the query optimizer then can look at the stored plan cache, or it will then go into, and it'll stop there, or it can then go into the relational engine, the execution plan phase. So from the query optimizer, it tells SQL Server what it thinks will be the best way. It looks at statistics. It will also look at constraints, foreign keys, triggers, those kinds of things, what is valid for this particular column. It then will produce that execution plan. And then from there, it goes to the execution engine where it then runs the query. A lot of stuff. So a more concise picture, and it's easier to see, is this picture here. And again, it's the same thing, but it's more precise. So one, it goes through the parser, the query parser. And there it just checks to make sure that the SQL is well formed. What do I mean by that? We write code, it always starts with select, then there's the from, the where, the group by, having, and order by. In FoxPro, oh my goodness, we can sort of mix those up. In SQL Server, nope, it's got to be written this way or it is not well formed. It has to be select, from, where, group by, having, and order by. But SQL Server processes it from the from first, and then the where, and then the group by, having, then it looks at the select, and then it looks at the order by. And the query parser tells us that. So not well formed example is here, and you can see I'm going to use the AdventureWorks 2017 database, and we can see select, from, having, group by. Now, I believe in FoxPro that would work. In SQL Server, not so much. So it's telling me that the keyword group is, there's a problem around there. And it's actually the having count star greater than 1 needs to come after the group by. So a correct example would be those being switched. And so the output again is the parse tree, and we know that it's logical steps. And again, if the data if it's the DDL query, it will not be optimized, okay? If it's a data manipulation language, the DML, then, and the parsing is correct, then it goes to the Algebrizer. And let's go look at some examples. Okay. Let me just talk to you real quick about my scripts. There's a 000 here. It goes into a whole lot more detail about some of the stuff that we are going to just sort of fly through, and I'm not going to discuss. It isn't also in the white paper, a lot of this. We are going to go to the example of the parser, and I'm going to make sure that I am using AdventureWorks, and then come here. And you can see the Algebrizer already at work. And we can see from the example in the slideshow that I don't even have to run this to know that it's going to give me that error. So let's go here. Another one. Again, we know that something's not right here. And so if we come here and we can now put it all together, and we can see that it is now working properly, and we get our results. So that's just the parser in action. And like I said, you can actually see where it's having issues with the query statements. Are there any questions, Tamar, at this point? Okay, I'm going to move on. Okay, so to the Algebrizer. Now, the Algebrizer resolves all of the objects within SQL Server. And it looks at the names, the objects, you know, even functions and such. So, and then it will also identify column levels and all the data types, and it resolves those names. And it looks for the group by and the max. So, next, so here we're trying to resolve objects, and we get the error message, invalid object name. So for production, and if I click here, this is where the problem is. It isn't a production, the schema isn't production, it is actually person. So once the Algebrizer is happy, it then passes the query process tree to the query optimizer. It also, that's where the hash is then produced, and it's basically that unique fingerprint, if you will, for the query optimizer. And that's what it'll do is it'll check to see if that is already in the plan cache. Okay, I already said that. So it's already in the plan cache. If there's a valid plan, the process stops and it just uses what's in the store, in the storage engine, which then reduces the overhead. So let's go look at that example. We'll be real quick about it. And this is 2. And so here you can already see it's already having issues. And we know why, right? Because it was using the wrong schema. And you'll see, I can't run them together because I have to run them separately. And there you go, it's happy. So, and there's just a couple of more examples. And here you can see where the column isn't correct. It should actually be phone number. And it also then determines, you know, the counts and where that is happening with the group bys. So that's all part of the Algebrizer. Okay, yay, we're getting into the query optimizer now. And this is where a lot of work is done. It models what the database relation, how the database relation engine works. It's what it's thinking. The most important pieces of the optimizer are the statistics, but it also takes into account the constraints of what's going on with the database and the tables that are involved. If the statistics are out of date or they, well, yes, they're out of date where their cardinality isn't up to current, you'll see the query optimizer do one thing when it should have done something else. That's why statistics are so important. Here I said, and so it then goes through the query process tree, checks out, you know, it'll check out the various joins and it'll try joining things differently to see what comes up with the least expensive plan. So the optimizer is based off a cost, and these costs are estimated. They are never actual. It's the required CPU and the I/O. If I can get the table all up into memory, we won't have a lot of I/O, but maybe to do that, the optimizer will say, hey, instead of using one processor on the computer, we're going to use all 8 of them, whatever, that it decides. So, and it will try to evaluate as many plans as possible, except when the plan is already exists. It will choose a low cost. Low cost always wins with the optimizer. The execution, it tries to execute the plan as fast as possible using the least number of resources. It's going to look at CPU and I/O. So, and yep, and I just said that, where if it's more the CPU, it'll select a more intense CPU if it will return the results faster. It will settle for a less efficient plan if it takes too much time to evaluate as many plans as possible. It doesn't choose the best plan. It finds the one with the least cost in the shortest time possible within the processor. So I'm going to skip these code examples because I really want to start going into reading these execution plans, and these code examples really overlap. So, so the query full cost, yes, and we got the processor tree, we got the statistics, and there we got the constraints. So all the things that the query optimizer is looking for. Let me go through this. Yep. Lowest cost. Good. I'm sorry. I want to get to a point here. Again, lowest cost. So this is where I want to be. Getting started with the graphical interface. And here we will cover much of the execution plan from trivial to full. So there are two types of execution plans. There is the estimated execution plan and the actual. So, and you can find them here on the graphical interface. To me, estimated, this part looks like a heart to me, so I look for the heart for estimated. Actual, it will give you the actual number of records and that kind of thing. That the execution, it's after the fact, so you have to run the query with the actual execution plan to have the execution plan show up. With the estimated execution plan, you just need to click that button and it will produce the estimated execution plan. So let's talk about these real quick and then we'll get into SSMS. The estimated execution plan, SQL Server does not execute the query. The optimizer inspects the query, determines the execution plan, either from the stored cache plan, or it goes through the process to return a new plan. However, it does not execute the query. It won't have runtime information like actual number of rows. The actual execution plan will go through all the steps and execute the query. We are basically requesting a plan with runtime information. So, and then there's a way to save the execution plan, and then there's a way to do a comparison. So let's get into SSMS. This is the fun stuff. So let's go here. So I'm going to, it's thinking. Okay, so I make sure that I'm here, which I am. I can see that up there. I am going to do never, never, ever. This is clearing the cache plan. Don't ever want to do this in a production system, okay? So I'm going to execute that. Yay. All right, so estimated execution plan. And you'll notice I'm going to click right up here, display estimated execution plan. And lo and behold, I'm going to zoom to fit. Here's our execution plan. You'll notice you'll have the messages and the execution plan. Okay. And then if I were to, let's go look at the actual. We're going to just do the actual. We still have that highlighted, but you'll notice we're going to click. Let me put here. Click over the messages. I'm going to click the actual execution plan. So if I click that, nothing happens. You have to run it for the execution plan to be produced. You'll notice with the actual, we have to run, we get the query results, we get the messages, and then we get the execution plan. Okay. So with that, we're going to be moving into, and that's, oh, I want to do the show plan. Perfect. So let me go back here, and we're going to run this one again, but we're going to do the estimated. I want to show this to you. And I can right-click here, and I can save this execution plan. Let's see if I can get this. Oh, it's not going to let me show you. Okay. That's it. That. So I'm going to right-click here in the Show Plans panel, and there is a Save Execution Plan As. So come here, and I am going to save, and I'm going to save this. Yes, I want to overwrite it. Thank you. Then what I'm going to do is I'm going to actually run this now. So I saved the estimated, and I'm now looking at the actual. And now, because they look similar, I want to actually compare them. So I can come here, go to the Save Estimate, open it, and look. It will do the plan comparison. What we did was we saved the execution plan for the estimated. We ran the actual for the same query, and now we're doing a comparison of that show plan. And you can see the one on the top is the actual. It says execution plan, and at the bottom you'll see where it's pulling the file name for the estimated. And what's really cool is we can actually come into the properties, and we can now see, you can see the difference between the estimated. There are no actual rows because it wasn't executed, versus what the actual did. There's other things like this is really, if you're running older versions of SQL Server, you might have a 70 there. 140 is the most current version. Memory is in kilobytes. And then the other thing you'll see here, 0 versus 1. And parallelism is how many CPUs it's running. And right now it's using 1. The other thing to look at is, there's nothing really else here to that's exciting news. It does look at like the subquery costs. Again, that is in milliseconds. So I'm going to close that down, and I'm going to close that show plan comparison down. So that's how we would save and compare execution plans. So let's go into the anatomy of these executions plans, and we'll get into here. So it's thinking. All right. So here we're going to talk about tooltips and other things. Now I'm going to just run the estimated, so I don't actually have to run the query. And let me select here and zoom in. So at the bottom, you will see that this query is using a clustered index seek right here. And it's saying that 100% of the cost is happening here. I can guarantee you there is cost to every single operation. The select is showing 0 cost, but there is some cost associated. But in a comparison of the whole of the clustered index seek versus the select, that it's pretty much 0, comparatively speaking. Now, usually people will read the execution plan from right to left. So, and that's the way the data flows. However, most of the information as on the whole would be on the select. It's the result operator. And here you can see the tooltips that are popping up. This gives you a narrowed version of what is in the property sheets. And you can see that you can see no actual number of rows because we ran the estimated. The other thing to note here, the tooltip text for the clustered index is much more extensive. But what if I want to see everything about it? Let me run the actual now. I just want to show this to you as well. So I'm going to run the actual. I actually have to run the query to get the result and the execution plan. And the clustered index seek looks, it's the same as the estimated one. However, on this, you will notice that it's also telling you this one of one. The first one is the actual records that were used or read, and then the estimated, what the query optimizer thought that this would take would be 1. So it's 1 for 1. So it did a great job of running this clustered index seek. And a clustered index seek is one of the fastest queries that you can, operators that you can run. The clustered index is the table as its whole, and you're using the primary key to drill in to the leaf level to that record of that table. And like I said, it is usually one of the fastest ways to do that. If I want to learn more about the clustered index seek, I can click into the properties. And there is a whole bunch going on here. And you can see the actual number of rows that were returned based off of the estimated. So, and what you're going to want to do when you're looking at these two numbers is how different are they? If the estimated number is vastly different from the actual number, you might have a statistics problem where it might need to be updated. And so you're going to be looking for things like that. Other things that are of interest, the defined values. Here, it's telling you what is it going to pull from the person address table. It's the address ID 1, address line 1, address line 2, city, postal code, and the row ID and the state ID. The row GUID. Okay. So the other thing to look at is, of course, we have the estimated CPU cost. You will never get an actual. It's always estimated. And it's a cost unit. And from all that I have read on execution plans, this number isn't extremely accurate. So it's just something. It's just something to keep your eye on. The subtree, let me see, the number of rows read, object. The object here is going to be the clustered index that is being used. And as you can see, it is using that clustered index, and it's using the PK, and it even tells you it's clustered, it's the person schema, and the table is address. The other interesting thing is here of interest usually is order. Let me pull that in. Hold on. I'm clicking. The order is true, okay? And right there. And that will become of interest in other operators. So that's something to also keep your eye on. The output list is just, what is being produced at the results level. Okay, and I'm going to go back to here. So that's cool. The other thing to notice is that, and all of these objects in the show plan has the tooltip, including the line. And if you notice, it's a very small line, and it actually is a graphical representation of the rows that are being pulled to the select. Okay, and then and it actually has properties as well. Now, it's not much different than the tooltips. And the select. The select is of particular interest because, again, it is one of, it represents the whole. So if we come and look at the properties here, we can see there's that what it's using as far as what version of the Optimizer execution plan it's using. And there, the subtree cost is actually showing the cost of what it was to do the clustered index seek. The other thing is optimization level. Optimization level is trivial here. And let's see if I can do this. There we go. It's trivial here. It's saying, hey, this is a simple query. It's good enough. And I'm just going to stop, without going through all of the execution plans that I could possibly look at. The other interesting thing here is parameter list. On a simple select statement, it will create a parameter, and we'll go back and look at that select statement, and you will notice, I'm going to do this. So the parameter list is saying at 1. So the optimizer created a parameter that I didn't tell it to do. It just did it on its own. And the column is the at 1, and the compiled value is that numerical value of 12753. It is a small int, okay? And if you know anything about primary keys, they're usually an int. And so you'll actually might see an implicit, convert implicit on queries here as well. And that can be a telltale sign that maybe you might need to do something different. Here, that is not the case. It did its job and it did it well. So there's that set. These are, it also, and if you run a query and you change any of these set values, it will change the hash, and the optimizer will have to go and do another optimization. It can't go back to the plan cache, and so that can also change whether it does the optimization and goes through all the steps, or it just gets to the storage engine and looks for the plan cache. So, and then you'll also notice here, and what's nice about this, there's way down here is a little ellipse right here, and you can click on that, and so you can see what's in there easier. So that's a good thing to look for. Let me click off that there, and there you go. So you can actually see the select statement that SQL Server is working from. And you'll notice again, I forgot to click, that there's that parameter. So where address ID equals that parameter. So if I go back, let me close that. If I go back to the select statement, you'll see that that wasn't parameterized. That was actually a number that I did, but that's what SQL Server did to figure out how to make a most efficient execution plan. And by parameterizing it, it can use that execution plan over and over and over again, because that at 1, it can be stored in the plan cache, and that content will remain the same. All right, so let's see. And I went over tooltip tabs, I went over properties, and I think we're done here. So here, then we're going to go to, let's start exploring. We have about a half hour to explore. Is there anybody that has any questions at this point?
Yeah, we have a number of them.
Okay.
Some of them are from a while back. Scott asked,
I'm sorry.
Is the optimizer specific to MS SQL, or do others have similar offerings?
the SSMS, there's the execution plan that there are other companies that create execution plan products, tools. I'm not sure if I'm answering this question correctly.
I think his question is more, do other back-end servers have optimizers as well?
Yeah, I can't answer that. My expertise is in Visual FoxPro as well as SQL Server. I do know, like with FoxPro, you know, if you create the select statement properly, that it can be Rushmore optimized. So my guess would say in FoxPro, yeah, it does go through that type of process as well.
Okay.
Another?
Yeah. I'm going to pick and choose because I know you have a lot more you want to get through. And Josh Klein asks, why bother with an estimated plan at all?
Well, excellent question. The reason you might want to do an estimate is if you have I have a number of procedures that take about, unfortunately, quite a long time to run because of all the manipulation it is doing. If I produce an estimated plan, I don't actually have to wait for that query to finish, and it will give me the estimated immediately. And what's also nice about the estimated is then you can then share it and have other people look at those execution plans. And just a real quick example, out here in SQL Server 2016, I can come here, I can open a file there. I can go to that estimated one that we were looking at earlier, and lo and behold, there you go. You can now look at, even though I don't have that database in this instance of SQL Server 2016, I can still look at the execution plans. I hope that answers that question.
Okay, let me give you one more now.
Sure.
Charles asks, have you had any really big aha moments as a result of learning and using show plans? And if so, can you talk about them?
I will, and that's an excellent segue into the next spot that we are heading, where we're going to explore the execution plans. Okay?
Okay, why don't you go ahead?
Okay, perfect. We have about a half hour left, and we can spend as much time here as possible. And I just want you to know, too, please email me. I love when people ask me questions about presentations. I love helping people, and I sincerely mean that. Just ask my boss, Rick. So again, we can talk about the distinct operators, but we're going to go straight into it. So again, here's all this information here that you can look at. Just an FYI, that if you have a developer that is not an owner, a creator, or a sysadmin, you actually have to give them access right to the show plan. And you can do that by saying grant show plan to. And here's a good example of that. Okay, so I'm getting ahead of myself. So let's go here. And I got my Adventures Works, yay. So, and I'm going to do I'm sitting on the actual, and I'll just execute it. I like seeing the actual run numbers. So, and it's thinking, there we go. All right, and before I talk about this, let's look at the query. That would help, right? So we're using a clustered index in this execution plan, and you'll notice it, and it's from the example that we just used. Okay, so and we're familiar with this pretty much already. Do show to fit. Okay, and so we see that one-to-one, and we've taken a pretty deep dive into what that looks like. However, what if I were to do, we're using the same table, right, in the same schema, but instead of doing the individual columns that we're specifically looking for, we're actually doing a star. Now, a lot of SQL Server DBAs would shoot you, not literally. They would be very upset with you if they saw a select star in your query. But let's go run this and see what it does. It produces the same result because we're using the same where, right? And you'll notice that we're still using the clustered index seek. Remember, a clustered index seek, a clustered index is the entire table. So by it using the clustered index, it has access to all of the fields, right? And so there's no harm, no foul in doing a star here, okay? So again, we've looked at that, okay, but let's go where we are doing the modified date. We're going to look at the modified date, okay? And this is very common. And just to talk about this a little bit, you have a modified date. It's a date time field. And I'm saying it's greater than N, and that is the code. So it represents an N bar chart, if you will. So, and here I'm saying 2014. Well, that's not a date time, Jody. Well, SQL Server can convert that. And what's really cool about this is the execution plan will show you what it is doing. So let me execute this. And you'll notice here, if we zoom in, it is now doing a clustered index scan. What do I mean by scan? It's having to go row by row by row by row through the clustered index. It's scanning the table. It's not necessarily a good thing to be doing. The other thing is, as you'll notice, is on here, is that the actual was, it produced 5,326 rows compared to the estimate, which was 5,326 rows. So that's good. All right. But, and here, I also just want you to note that the, that line, look how thick it is compared to the one we had before, where we were able to use that clustered index seek, right? Where it was very tiny, very thin line. And here we can see where the actual rows in the tooltip text, and I'm going to have to go to the properties here because it doesn't allow me to do this. You can see that the actual versus the estimated are identical, right? So that's really cool. But you will notice, look how many rows it had to read through, 19,614. So let's go back here and let's go check out this clustered index scan. And I'm already apologizing that this is a little tiny. And we see the defined values that we have in here. Okay, but I want to go down here to the, let's see, output list. This is what I'm looking for. Here's the predicate. And I'm going to, and this is where that where clause is. And I'm going to zoom in. Okay, and you'll notice, look what it's doing with the modified date, the where, and then it is, it's doing a greater than, and you'll notice it takes care of the date time issue. And any time that you just put a year there, it will then assume 0101. One of my Sage DBAs introduced me to that little thing, and I absolutely love it. So that's really cool to understand what the SQL Server is actually seeing versus what you actually submitted. And there was one other thing I wanted to show you. If I don't find it, that's okay. I'll just move on. I'm going to move on, and hopefully we'll catch up with it. So, and then with the select statement properties, we will note that there's that parameter list. I think this is where I was heading. And we'll see that, let me go zoom in, the parameter list, and we can see that it parameterized this. And you'll notice that it changed it to an n varchar 4000, okay? And oh, there's the query hash right there too. And you'll notice that the other thing to note is that it actually did a full optimization level. And you'll notice here, the reason it terminated early, it had a good enough plan found. It didn't go to the end of itself. It said, oh, this one's good enough, I'm done. So lots to look at these execution plans. Let's move on. So this is a covering index example. So here, it's going to be doing an index seek. However, it's going to be a non-clustered index. And it's what it's called as a covering index. This index on the address table is address line 1 plus address line 2 plus city, the state province, and the postal code. So if I run this, and you'll notice the predicate, my where clause, I'm saying address 1, which is the top part of this index, is like, anything that begins with 100. So and I have my actual, so I'm going to run this. All right, and it returned 29 records. And if I zoom in, you'll notice on the index seek, it's non-clustered, and that it ran at 5.8 milliseconds, and then it got 29 out of 40. So what happened is the estimated number of rows was 40 compared to just 29. That may or may not be an issue, but it's something maybe to look at. The other thing too is we were able to do an index seek. And again, you can also, it's like 15 minutes left, so I want to show a couple things, but I want to also move on. So you will notice that the predicate, there it is, and then the seek predicates. So you can look and see what it's doing to those predicates here. Let's go here. And this is on the start. Let's do there. So you can see what SQL Server is doing. It's doing a greater than the N100, and then it's doing a less than 10 1/4. Interesting, right? Just some fun stuff to see what SQL Server is thinking. Okay. Close that, and we're good enough here. So let's go back, and you'll notice that the little line is showing the actual versus the estimated. And then we come here to the properties, and we'll notice that, look, it came up with a trivial plan, and we can then, that's the one thing. So it's actually doing its job, and it's doing it pretty well is what I think it's doing here. So if I come back here to the execution plan, and I want to go now to we're going to add a column, okay? That's all we're going to do. We're going to add the modified date, okay? And it's part of the address table. If we come here, so there's that modified date right there. So, but let me show you that it is not part of this index, okay? Nowhere is that modified there. So what is SQL Server going to be doing? It's doing a, and I did not have a where clause on there too. So, but it had to go, it's doing a clustered index scan. If you look at the rows, it's pulling back all of the rows. It didn't do the non-clustered index scan. It did the clustered. So it ignored the covering index that we used above and went straight to the clustered index. Interesting. And it's all because we added that modified date. Let's go and look at another one. So, whoop, it already says. So here, what's it going to do now? We're line 1, and we've already seen this. We know what it's going to do. It's going to do the index seek on the non-clustered. So yeah, we're pretty good about that, right? And you'll notice the estimated, the actual returned. Let me click on that. It actually returned 2,084 records, where the estimate said 2080. So, okay, so what happens if I do this one? Address line 1 and address line 2 are part of that covering index. So what's it going to do? Again, it's going to do that clustered index seek. But you'll notice that the actual is 16 out of 113 records. So that might be something to look at. May or may not. It all depends. So let's go here. And this one will do similar things. Again, it's address line 1, address line 2, and city. So it's going to do a non, because it's covering, right? So what if we take away that one and we just use address line 2 and city? It does an index scan. Notice that it is 71 out of actual versus 139 out of estimated. The other thing is it's scanning the index, because address line 2 and city, even though they're part of the index, it has to start with address line 1. So as soon as you take away that beginning part of that index from the where clause, it's going to have to do, and it's going to force a scan. And if you notice, let's see, it's having to go through all of those tables. So, but I want to continue to move on. So what happens if, what if I do the postal code? The postal code was part of the that covering index, but we know from the example above, it'll probably be an index scan, right? And we are right. We zoom in, and it's an index scan. It's a non-clustered, and look at that, it's 10 for 10. So it actually did what it was supposed to do. But if you notice here, right here, right there, we have a missing index. Now, SQL Server isn't, it's a suggestion, and it might be something that you want to look at, but you might not. It depends on how often you use that kind of query from the postal code. Is that something that you use frequently, and you're going to have to know how your customers use the database to maybe not create that index for that, or tweak one. But figuring out how to get to that missing index information, that's a whole nother other topic in and of itself. So, and you'll notice the thick line, and it's showing that there, the number of rows it had to read was the 19,614 to get to the 10. Okay, so what happens if we add the modified date? And we have that address. And I'm pretty sure we already know what that is it's going to do, whoa, look at that. That's different. Let me zoom in. Here, what's happening is at the top, it's using the non-clustered index seek. So it's drilling into address line 1, right? And it returns 3 of the out of 3 actual over the 73 estimated. But then it goes to a key lookup, and it's because the modified date. The modified date isn't part of the index that is being, the non-clustered index that is being seeked. It's actually then going to the clustered index where all the data resides, and it goes and finds the modified date column information, and it does it through a key lookup through the primary key, and it tells you that here. Let's go into the properties. And you can look here at the output list, and it's just the modified date, and it's coming from a key lookup. And then the object, you can see that it is using the index, the clustered index at this point. So, and it tells you that right there, okay? And so you can just continue to drill down and see what SQL Server is thinking and how it's getting to the information that you requested in your query. So let's go back there. So, and then, so you can see that it just goes 3 times to the clustered index, it pulls that data, and it comes into a nested loop. A nested loop, it's an inner join where it's joining the information coming from the clustered index and the index seek and joins them together to output where you have everything from the covering index, which is the address line 1, 2, city, state, province, ID, and postal code, and then it pulls in the modified date from the clustered index. For it to do a nested loops, it is the output from the index seek and the key lookup are ordered, and that's where I was showing you on the properties. If you come down here, is that ordered true? So, and that's important when you go to look at other operators where this is false, and then it'll do something different. It'll actually do a sort, and that sorts aren't necessarily the bestest thing in the whole world to do. They can be quite expensive when it comes to that. So then from there, we can see that it produces the 3 records that meet this criteria. So a lot of information going on here about this one little query and how one line of code, a column, can make a difference. Okay. And this is another example of a key lookup where the last date, and here it's going to do, we know it's going to do a seek. And then, oh, let me just show you this one. This one's a good one. This one, we know it's going to do an index seek. So here, zoom to fit. Oh, that didn't do that so good. Let's do this. Zoom to fit. So we know it does an index seek. It's doing the key lookup. All right. And you'll notice that it's 5 of 2. All right. of where it's trying actual 5 versus, you know, the 2 that were estimated. All right. But what happens is if I just change one thing, so the last name is GE, like GE. Here it is like G. So, and so I'm going to execute this. But look at that. It is doing a clustered index scan instead. And you have a missing index. And you'll notice the actual row versus the estimated rows isn't too terrible here, so which isn't bad. But why did it go to the clustered index scan? And what it comes down to is statistics. And I'm not going into that now because we're running out of time, but I give you some information about interrogating statistics. So another operator I would like to show you is the computed scalar. So let's go here. This is very similar, but you'll notice I'm doing an is null. You know, if the first name's null, I'm concatenating the names together. And so I have a space 0, a space 1. So let's do that. If I execute that and come here, we are doing, let's fit it. We are doing an index seek. Yay. So, but let's go check that out. Oh, this is what I want to check out, the compute scalar. So the output list. Output, yep. And we have our expression. Okay, and there's no parallel. Oh, this is what I'm looking for. Sometimes I get lost in this. And here, you'll look at this. It's doing some things that I don't want to see. And it's doing a convert implicit n bar char 1. Now, why is it doing that? And you'll notice it's also doing, instead of the is null, it's saying the is null is a function of SQL Server. It's not an ANSI standard. So it's actually writing code that says is null then. So it's doing a case when statement in SQL Server. Really cool to see what SQL Server would do. But the convert implicit is really interesting. So let me do this. Let me go down, and instead of using I like seeing these spaces. It's really easy for me to read, right? But if I come here, because the the person, you'll notice that they're all n bar chars, okay? So what I did was I'm doing an n and then the varchar. This is the double bit content. So let's see what SQL Server does with this one. Now, not much has changed, right? But let's come look at this and look at these properties. And now look, my convert implicit, which is an expensive thing to do in SQL Server, is now gone because I took the time to figure out what would make this query faster. All right, and I mean, there are more things. There's the merge join, there's the hash, there's a hash aggregate, and we're really running out of time. Again, this was a lot of fun to do. And so go through them, take your time and look at them. And I just want to show you one more thing. I went down here, and there's a lot that we're going to miss. What would happen if I did a view? So in AdventureWorks, there's a view, all right? And I'm going to execute that. Here's this execution plan, and it goes on and on and on. You save no time for SQL Server to having to run the execution plan. So views are great, but know that SQL Server and the query optimizer still has to do its work, right? And that is huge. And I mean, that's even very hard to read. So that's why we have third-party tools like Century1 Plan Explorer, where it's thinking, has a great way of taking those execution plans and making it look a lot prettier. It is so much easier to read this than it was in SSMS. So I would highly recommend Century1 Plan Explorer. This version is free. Gotta like that. All right. So let's go back here. So we went through all of this. I mean, every single piece of it, as much as we could. So, and then I talked about the other execution Plan Explorer tools. There's the Century1, which I quickly demonstrated. And then there's one that's really interesting, which I have not had time to do, is the Apex SQL Plan. That's something that you might want to check out too. And it's also free. So my resources, oh my gosh, there is so much out there. The best thing to do is get this book, and I live with it, is Grant Fritchie's SQL Server Execution Plan. Excellent, excellent book. It is also for free for a download for a PDF, but it's worth the extra money. And if you're like me, you like to write in books. So the other resources, show plan logicals and physical operations. SQL Server does a great job documenting this. There's about 111. Some of these operators are visible and some are not. Great resource there. SQL Server users groups and conferences. Google it. The SQL Server community is absolutely fabulous. I want to say a huge thank you to Ed Wagner. He is the coordinator of SPID, and he also goes to GLASS. And people like him take people like me under their wing and help me get better at SQL Server and knowing all the great stuff that is available with SQL Server. So summary, execution plans. Oh my gosh, deep dive, basics. We just peeled back a layer. Getting started with the graphical interface. We went through the graphical interface execution. We went through the property sheets, the tooltips, the data line arrows, all that. And getting started, we went through some examples from covering indexes to how your SQL statement, by adding one column, can do to change what it can do to change the execution plan, and then other execution plan tools. And we just scratched the surface. Rock on in SQL Server. There's my son David again. Hi, David. And there's me. Please fill out your evaluations. And I believe that this is done, and then we'll go over and you can ask me questions all you want. Please email me as well. Call me. I'd love to hear from you too. This COVID thing is driving me nuts because I don't get to see as many people as I would like. Take care.
Thank you, Jody. And as Jody said, she now has a Q&A session. So if you had a question that didn't get answered, go over to the sessions area and find Jody's Q&A. See you all in a little while for the next session.